Hey guys, welcome to a lesson on primes and composites as well as the Sieve of Eratosthenes. First, let's go over some simple definitions that we probably already know. Prime or a prime number is a positive integer p whose only positive divisors are 1 and p. Now, a composite or a composite number is a positive integer c with any other positive divisors besides 1 and c. Okay, let's talk identifying primes now. When finding primes, it can get hard when the numbers get larger. If we want to use an easier way to identify big prime numbers, we can use a method called Sieve of Eratosthenes. Okay, let's take a look at this right here. So as you can see, we have numbers from 2 through 100, and it can really go infinitely. It would work. We're just working with up to 100. Okay, so the first step when applying this method is you would circle the first number on your list, which will always be 2, and then you cross out all multiples of 2, except of course not including 2 because it's a prime number. So you see that here. Everything is kind of just crossed out or like blanked out, and 2 is highlighted because that is our first prime number in our list. So the next step is to move on to the next number that's not shaded out, crossed out, and that would be 3 in this case. We would highlight 3 red or circle it, whatever. We would acknowledge that it is a prime and then cross out all multiples of that number. So here's what it would look like. 3 is now identified as a prime number and all multiples of 3 are crossed out. And then we would do what we did again. Move on to the next number that is not shaded out, crossed out, and that would be 5. So again, we have that here. And now, let's do that again. We see that the next number is 7, so we'll do that. Alright, so we have all our numbers crossed out, and as you can see, we have our primes. We don't need to go further, and the reason is that because our highest number on this list is 100, you only need to try the numbers up to the square root of that number, which is 10. As you can see, we've only had to try out these numbers as shown, and now we have identified all the prime numbers right here. So that's how it works, and as I said before, it can go infinitely. It can go up to like 200. It can go infinitely. So this is just an example of identifying prime numbers up to 100. Alright, so that was Sieve of Eratosthenes. Let's summarize the steps really quick. Okay, so steps summarized. Circle the number 2 because that'll always be the first number. Cross out multiples of 2, we did that. Move to the next number that is not crossed out, in this case 3. Circle it or acknowledge it that it's a prime. Cross out all multiples of 3, move on to the next number that is not crossed out, and repeat the steps. And that is how you identify primes. So now let's wonder about something. How many primes are there? So your instinct might tell you that there's an infinite amount of primes, meaning it'll go on forever. But if you say something is true, we are going to have to prove it. So we are going to prove that there is an infinite number of primes. And to do this, we're going to do proof by contradiction. We're going to say that there's actually a finite amount of primes, meaning it stops somewhere, and we're going to prove that that can't be the case. So to start off, let's have a finite amount of primes. Let's have our prime 1, prime 2, onto prime n. So this is the last prime on our list because we're assuming that there's a finite amount. So here's our little list here. And let's introduce a new value, a new number. Let's say q. And the value of q is p1 times prime 2, the multiplication of all of these primes in our list. So basically, q is a composite number, and its divisors are only the primes from these lists. Prime 1 divides it, prime 2, prime 3, prime n will divide q perfectly. And these are the only numbers. However, when we have q plus 1, meaning over here, now this new value is no longer divided by any prime number because you added 1 to it. And so clearly q plus 1, whatever number value that is, that means that it is a prime number. So we've just showed that in this supposedly finite list that there's actually another number that's not only larger but also a prime. So it can't be true that there's a finite amount of primes. So that's the proof of why there's an infinite amount of primes. Proof by contradiction. Thank you for watching.